This topic will be about how to find unknown angles when dealing with transversals intersecting parallel lines. So the question that we're looking at here is asking us to find out all the unknown angles in here. And then is this line here, BD, parallel to EF? So we'll just start with some key ideas, and those being based on what are some relationships between the transversal and the parallel line. Okay, so as you can see in the bit that I just posted in here, when dealing with a transversal intersecting two parallel lines, you've got relationships here. So the corresponding angles are equal, corresponding here, for example, A and E being equal. Then the alternate interior angles being equal. So you can see that C and F, for example. So C here, F there. So they're alternating, but they're still within the parallel lines. Then the alternating exterior angles being equal. So A and H, for example. So A and H, they are alternating. They're on opposite sides of the transversal. Transversal being the line that cuts through the parallel lines. So we can see that A and H are equal. You know which ones are the parallel lines because they're the ones with the arrows. So if I see one arrow and then another line with an arrow, that's telling me that these two lines are parallel. And then the last one here, the interior angles on the same side of the transversal are supplementary. Supplementary meaning adding to 180. So down here, C plus E. So C plus E. So if you want to think about it, this form's kind of like a C itself. So if you see that in the corners of C, they should add up to 180 degrees. Okay, so let's apply some of that to this question over here. So I'm going to do one thing just to extend the line a little bit. So I can see this line can be extended down and over and down and up if you wanted to look up that way. Okay, if you wanted to draw it extended that way, that's fine. If this doesn't work for you, you don't have to draw these extra lines. Okay, so we have that there. And then we'll just go and make sure that we know that that's still E there. Okay, and then let's start going through what we know. We are given these red arrows, which tell me that this line here, CF, is parallel to this one here, DE. Okay, so we've got some given things. So CF is parallel to DE. We also know this angle is 105 degrees. So when we name the angles, there's three letters. It's always going to be the middle letter that we're actually talking about. So this is angle B, but from what perspective is it? It's from A to B to C. So I know it's the inside here. That's 105. So if I go and label that as angle ABC, that's 105. Okay, so that's just something that we know. Then from there, let's move to ABF. So here's ABF. So we're focused on this part right here, this angle. And we're going to look for something that's supplementary to that. So again, supplementary meaning adds to 180. Okay, so then we're going to look at ABC. When you add this angle here plus the unknown, you should get 180 because we're dealing with a straight line. Okay, this line here is 180 degrees. So what we're actually looking for is angle ABF. So angle ABF is a straight line, which is 180 degrees, minus what we know, which is 105. So that's 105 degrees, and that will equal 75 degrees. Okay, so now we know this angle here is 75 degrees. Okay, and again, that's angle ABF. Next one. Let's check out some of the other rules that we would have known with angles. So we're going to look at angle CBD. So we're looking at this angle here. That is going to be vertically opposite from the angle that we just found. And the vertically opposite angles are equal. So now we know these two angles are equal. Okay, so we're going to say that angle CBD also equals 75 degrees. Next one. We're going to look for something that's corresponding. Okay, so our corresponding angle, let's go from BDE. So we're looking at this angle here. And let's look at ABF. So the angles that we're comparing are here, ABF, to here, ADE. So when we see corresponding angles, we're going to say that they are also equal. So now we know that angle BDE also equals 75 degrees. Okay. Then we're also given an angle. So we know that angle FBE is equal to DEB. So DEB, let's just start with that. Angle DEB is 36 degrees. So that's this one up here. Okay. FBE, so F, where is F? Right here. FBE. So we're focusing on this angle here. Okay. And our idea here is it's alternate interior angles, because we know angle DEB is 36. So we're going to use the alternate interior angle. So we are allowed at this point now to say that because angle FEB equals angle DEB, we can now say that angle FEB also equals 36 degrees. Okay, because we saw down here, angle DEB was 36, and that one was given. Let's move on to, let's do sum of interior angles. Okay, so now we're going to look at a triangle. Okay, so when we look at a triangle, we've got a couple triangles that we're dealing with in here. We've got this triangle here and this one over here. So let's just start with the angle FEB. So FEB, so that's this angle right there, plus FBE, so that's this angle right there. So that plus what we know, EFB, so EFB being 75. So 75 plus an unknown plus this angle up here. We already figured out this was 36. So let's just put 36 right there. Okay, so 36 is there. So we have 75 plus 36 should give us this when we take it from 180. So because we're dealing with the idea of the sum of the interior angles in a triangle being 180, what we're actually looking for is angle FEB. So angle FEB equals 180 take away 75 and 36. So I'll have to just put it in a line down here. 180 minus 36 and 75. And that will equal 69 degrees. Okay, so that's this angle right here. 69 degrees. Okay, one more angle to figure out. So now we know this is 36. Sorry, this one here is 36. We already figured out the angle here, ABE. Or sorry, ABF. We figured that one out right here. So that's 75 degrees. So we know this is 75 from before. I'll just put that number up there so we can see it. And by the work that we did over here to find ADE, we knew that that was also 75 down there. Okay, so we're dealing with 36, 75, something for this angle here. That should sound familiar because the other triangle had similar numbers. So to figure out the angle here, which was angle EBD, so we'll go angle EBD. It's a triangle, so 180. Take the two angles you know, 36 minus 75, and get the angle for right here. Okay, so EBD. So EBD. So we're looking for this angle there. Remember, it's the middle letter that tells you where to look for the angles. So that again was 69 degrees. Okay, so at this point we've answered part A. We've got all of the angles. Remember, an angle starts with this angle symbol and then the location. And it's always the middle letter that tells you what angle you're trying to solve for. But what perspective you're solving from, you need the three letters to tell you that. Okay, so let's move to B. Is BD parallel to EF, and how do you know? So where is this? Where is BD? BD is right here. I don't see any red arrows on there telling me that they're parallel to something else, so we're going to have to prove that. So it's asking us to prove that it's parallel to this line here, EF. Okay, so all this work was A, and I just have just enough room down here for B. So B, we want to say that yes, BD is parallel to EF. So we're going to say BD is parallel to EF. Because FE, you could have put therefore, but I'm just running out of room, so we'll just put because. Angle FEB and EB are equal alternate interior angles. So this angle equals the alternate interior angle of angle EBD. Okay, so again, that topic was about a transversal crossing parallel lines and being able to figure out the angles, dealing with different ideas like corresponding angles, alternate interior angles, alternate exterior angles, and interior angles on the same side of the transversal.